Dear students, today we are going to discuss about carrier transport, that is drift and diffusion current. Okay, so in case of conductors, only drift current is responsible. Okay, but in case of semiconductors, both the current, drift and diffusion are responsible for generating current in semiconductors. Okay, so two currents we are going to discuss in detail. And moreover, even though the two currents are present in the semiconductor, the overall current density, so current density will be represented by J. So the overall current density is the sum of drift and diffusion current. Okay, sum of drift and diffusion current. So that I can write J drift plus J diffusion. J drift and J diffusion. Okay, so in detail we can discuss what is drift current and diffusion current. So what you have to remember is in conductors, drift current. Okay, due to the drift process, the current will be generating. But in case of semiconductors, both are responsible. Drift and diffusion, both are responsible, right? So this is what we have to remember. So drift and diffusion are responsible for generating current in the semiconductor, right? So first I am going to explain about drift current. What is meant by drift current and how it is produced? Okay, and what is the direction of the drift current? Okay, so first we are going to discuss what is the definition. Okay, that is how it is produced, how this drift current is produced, first part. And the next part, what is the direction of the drift current. Okay, this is what we are going to discuss now. So first, what is the drift current? Okay, so by means of the external electric field, we are going to move the charge carriers. So for example, now you consider one semiconductor. Okay, this is the semiconductor. Okay, so semiconductor means two charge carrier. Here I write the name semiconductor. Alright, so inside the semiconductor, two charge carriers are there. What are that? This is electrons. Okay, so electrons are positive charge. This is represents electrons. Electrons are negatively charged particle. Okay, and then holes also present here. So now you see these are the holes. So in semiconductor both are possible, right? So now I am going to connect this semiconductor with the external electric field. Okay, external electric field. Now you see this is the positive terminal of the battery and this is the negative terminal of the battery, right? And the holes. So holes are, this is holes. Holes are positively charged. So these two are connected like this. So what will happen? Electrons are negatively charged. So this is negative charge and this is positive charge. So automatically the electrons will be moving towards the positive terminal of the battery. So here I can write electron motion. Electron motion will be in this direction towards the positive terminal of the battery, right? So next, holes. So holes means positively charged. So all the positive charges will be attracted towards negative terminal of the battery. So hole motion will be in this direction. So I can write this is the direction of the motion of the holes. Okay, so now you see in which direction the drift current will be there. Okay, here electron motion is here and the hole motion is there. Overall direction of this drift current will be along the direction of the holes. Okay, it should be opposite to the electron motion. This already we know in the conventional current direction. So the current will be opposite to that of the electron motion and is along the same direction as that of the hole motion. So drift current. Okay, so due to this external field, listen carefully, due to the external field, the charge carriers are drifted. Okay, electrons are drifted to the positive charge and holes are drifted towards the negative charge. So due to this, the current will be produced. That current is called drift current. Okay, so how can we define the drift current? I will write in the next page. So what is the definition for drift current? What is the definition for drift current? So now listen, that it arises, the drift current arises from the movement of charge carriers in response to an applied electric field. Okay, so when we apply the electric field, then only the drift current will be produced due to the movement of charge carriers. So electrons move in one direction and the holes move in other direction, so that the movement of charge carrier produces the current. That current is called drift current. Okay, so I hope you understand what is the definition for the drift current. And then, so the drift current, that means the external force only making the charge carriers to move. Okay, so what is the velocity associated with the charge carriers? The velocity is drift velocity. What is the name of the velocity? Drift velocity, by the application of the external field. Okay, so the drift velocity increases. The drift velocity increases with increasing electric field. If the electric field is increasing, then the drift velocity is also increases. So now the drift velocity increases with increasing electric field. With increasing electric field. Okay, so if we increase the electric field, automatically the drift velocity is also increases. So that what it will do, the drift velocity contributes, the drift velocity, simply we can write like this, contributes to the mobility of the carrier. What is mean by mobility? So mobility is nothing but how the electrons are getting drift velocity by the application of electric field within the area. So mobility is represented by mu of the carriers. So the general formula, now listen, we are applying the electric field, so drift velocity is created, right? So mobility is equal to, how can we define the mobility of the charge carrier? Drift velocity by electric field. This is the general formula to find the mobility of the charge carriers. Mu is equal to Vd by E. Here Vd is the drift velocity and E is the applied electric field. Okay, so from this we can write Vd is equal to mu into E. Vd is equal to mu into E. Mu is the mobility and E is the applied electric field. Okay, and then we discussed the direction also. So what is the direction? The drift velocity will be along the direction of the whole motion, and it should be opposite to the motion of the electrons. Okay, this already we discussed. And this drift current always obeys. Okay, this is the second point, and the next point is the drift velocity obeys the Ohm's law. Okay, it obeys Ohm's law. Okay, and then Ohm's law. Okay, and then this drift velocity is mainly influenced by the external field. That is what we have to remember. It is mainly influenced by external field. As well as along with that, charge carrier concentration also. How many charge carriers are present? Accordingly also the current production will be there. Okay, so concentration. So mainly influenced by two things. One is external field and another one is charge carrier concentration. Charge carrier concentration. So this is what you have to understand about the drift current. Okay. So what is drift current we discussed? Now you see the drift current is produced by the application of external electric field. Okay. So what is the direction of electrons? What is the direction of hole motion? Everything we have discussed. So what is the definition we discussed for this drift current? So drift current arises from the movement of charge carriers in response to an applied electric field. Okay, when we increase the electric field, the drift velocity is also increases. So this drift velocity contributes to the mobility of the carrier. So mobility is equal to Vd by E, and then Vd is equal to mu into E. And this drift velocity obeys the Ohm's law, and moreover this drift current is mainly influenced by two things. One is the external electric field and the charge carrier concentration. Okay. So now we are going to the calculation part of the drift current. Okay. So what is the formula we can get to find the drift current? Okay. So now listen carefully. Here two charge carriers are there. What are the two charge carriers? One is electron and then holes. Okay. So whatever we are finding, that means drift velocity means it should be for both. Drift current also produced by both the charge carriers. So we are going to discuss step by step. The first step is the drift velocity of electron. The drift velocity of electron is given by, okay, the drift velocity of electron is given by the application of the external electric field. So here actually drift velocity means Vd, but here for our convenience I am going to write Vn. Vn is equal to mu n into E. Just now we have discussed Vd is equal to mu into E. Here n represents electron. N represents electrons. The same thing I am going to write for holes also. So the drift velocity of hole is given by, generally holes will be represented by P. So Vp is equal to mu P into E, right? So I can able to explain everything. Vn and Vp are the drift velocities of electron and hole respectively. Right? And then what are the other terms we are having? Mu n and mu p. So mu n and mu p are the mobilities of charge carriers, mobilities of electron and hole respectively. And what is E? Is the applied electric field. Capital E is the applied electric field. Applied electric field, right? Applied electric field. Okay. What is the next step? Now I am going to write the drift current density. The drift current density. So what is the current density? How we are going to find? So the drift current density due to free electron is given by. Now listen. As we know well, if the current passing through the conductor can be calculated by using the formula I is equal to N E A V D. What is this N represents here? N is the number of charge carriers, E is the charge of the carrier, A is the area of the conductor, and Vd is the drift velocity. Okay. So current density means current density is represented by the letter J. J is equal to I by A. I divided by A. So which is remaining here? N E V D. Okay, J is equal to N E V D. Okay, so here for electron, how can we write? N is there, charge of, that is number of the electrons, and E is the charge of the electron, and instead of Vd, I am going to write Vn. This is the drift velocity of the electron we mentioned. So that I am going to write NeVn. So what is the value of Vn we are having here? So N into E into, instead of Vn, I am going to write mu N into E. Okay, so this I have written for J. So Jn, what is Jn? The current density of free electron. Jn represents the current density of free electron. So same thing we can write for hole also. Directly I am going to write this. The drift current density, the drift current density due to hole is given by, now what is the current density of hole? Jp. Jp is equal to, instead of N, I am going to write P E mu P into E. Can you able to understand this? Okay, Jp is equal to P E mu P into E. So this is Jn and this is Jp, that is current density due to electron and current density due to hole. Now I am going to combine both to get the current density, okay, drift current density. So in next page I am going to write the overall current density, okay, due to drift is given by, okay, so J is equal to Jn plus Jp, right? So this is the current density due to drift, which is equal to, what is Jn value? En mu n into E, right? Plus what is Jp? Ep mu P into E. See, these two terms are common in both the terms. So I am going to take out E into capital E. So which is remaining inside? N into mu N plus P into mu P. Okay. So this is the overall current density due to electrons as well as hole. Okay. So this is what drift current density formula. Drift current density formula. J is equal to E into N mu N plus P into mu P. So E is the charge of the charge of the particle, okay, and capital E is the applied electric field, N is the number of the electrons, mu N is the mobility of the electron, and P is the number of holes, and mu P is the mobility of the holes. Okay, so J is equal to, this is the expression. So this expression represents overall current density due to electrons and holes. Okay, so I hope you understand what is drift current and what is the direction it flows, and what is the expression by means of this electrons and holes also we completed, right? So next we have to discuss about diffusion current. So what is diffusion current and which direction it flows and what is the expression, that thing also we are going to discuss. So diffusion current. So from the name we can understand very easily diffusion current. So what is mean by diffusion current? The movement of charge carriers from higher concentration to lower concentration, so that the diffusion takes place from higher region to the lower region. It creates the current. That current is called diffusion current. So by means of diagram only I can able to explain it. So now you see, this is the semiconductor. This is the semiconductor. Two types of semiconductors we are having. For example, I am considering N-type semiconductor. So as you know well, N-type semiconductor means electrons are the majority charge carriers. Now you see here more number of electrons. Okay, so now I considered the N-type semiconductor. If you see this diagram, here lower concentration of electrons, and this side if you see higher concentration of electrons, So what will happen? this higher concentration, the electrons are higher here, okay, so it will try to diffuse to the lower concentration, okay, so that the electrons will move from this higher concentration to lower concentration to form the equilibrium, okay. So the nature's attempt always, it should attain the equilibrium condition, so the movement of charge carriers from higher concentration to lower concentration generates drift current due to the diffusion, okay. So this is called diffusion current. So this occurs when the diffusion current will be produced. This kind of current will be produced due to the, when the semiconductor is doped, okay, that time it will be non-uniformly doped, okay. What is the meaning of doping? Adding impurities to the semiconductor. While doping, if it is done non-uniformly, what will happen? There is a non-uniform distribution of carriers will takes place. See here more number of charge carriers are present, here less number of charge carrier is present. So due to this non-uniform distribution of this charge carrier, okay, the diffusion current will be occurred, okay. So generally the nature's way of attaining equilibrium is from higher to lower concentration, the process is diffusion, okay. But this process does not require any external electric field. That is very important. In previous case, in drift current, we have discussed that external electric field is important, but in this case there is no need of external electric field. Then how the diffusion takes place, how the charge carriers are getting energy to cross from higher concentration to the lower concentration. Now listen carefully. This is N-type semiconductor. So electrons are the majority charge carriers. See, at one particular area, more number of negative charges are accumulated. Okay. So negative charges, what is the meaning? Like charges repel each other. What will do? Like charges repulse. So due to that repulsive force, this charge carriers are getting energy to cross from higher concentration to the lower concentration, so that eventually it attains uniform distribution. So that it creates the diffusion current. So the charge carriers are moving means what? The motion of the electrons. The motion of the electron is nothing but current, so that the current will be produced. Same thing for p-type also we can discuss. For p-type means holes will be there, so hole direction. So what is the direction of the diffusion current? Okay, so already we know that this is the direction of the movement of electron, means the diffusion current direction will be opposite. So J diffusion will be in the opposite direction of the electron movement, right? I hope you understand what is the diffusion current, how it is produced. Okay, so here the diffusion current is proportional to the concentration gradient. What is that? Concentration gradient. So now we have to understand what is the concentration gradient. So concentration gradient is the difference in concentration of electrons or holes in a given area. Now you see, in this area more number of electrons, this area less number of electrons. So this is only mentioned by concentration gradient. So I will write here, the concentration gradient is the difference in concentration of electrons or holes, anything, okay, or holes in a given area, So now you see difference, here very less, here very high. So this is called concentration gradient, okay. So how to understand the diffusion current generally, in the sense, for example, if you are using the room freshener, so this is the room, you are pressing the room freshener at one point, but what is happening? It will spread to the whole room. How it is happening? Due to the process of diffusion only. Not only the room freshener, for example, any bad odor, okay, smell, any bad smell, that will also spread to the whole room. So that is due to the diffusion. Due to that process only this current is also producing from higher concentration to the lower concentration. That's what the diffusion current. Okay, so this is happening because of the nature's attempt to reduce concentration gradient to zero. That means there won't be any difference. It should be uniformly distributed. It should be uniformly distributed. So that is what the concept for diffusion current. Okay, but this process does not occur in conductors. That we have to remember carefully. So this diffusion current will not be produced in case of the conductor. Okay, and in previous case the drift current obeys the Ohm's law, but this diffusion current obeys the Fick's law. Fick's law. Okay, it explains the flux of the diffusion. So that is not required for us. You just remember it does not obey the Ohm's law, it obeys the Fick's law. That much is enough, right? And then now I am going to write the definition for diffusion current. Okay, I will write in the next page. And what is the formula for diffusion current? Okay, so first let me write the definition for diffusion current. So diffusion current, the movement of charge carriers, from higher concentration to lower concentration generates diffusion current. Right? So next we have to discuss the formula for diffusion current. Okay, so let us discuss that. So already I said it depends on that means this diffusion current depends on the concentration gradient. Okay, so now if the concentration gradient is difference in the concentration, right? So concentration gradient. So if the concentration gradient is high, okay, then diffusion current is also high. Right? If the concentration gradient is low, then automatically diffusion current is also low. This you have to understand. The difference is more, the current will be more. The difference is less, the current will be less. Okay. So now I am going to write the concentration gradient for N-type semiconductor. The concentration gradient for N-type. Okay, so the concentration here Jn, what is Jn? Current density. Jn is current density due to electrons. N represents electrons, which is proportional to dN by dx. What is dN by dx? That is nothing but concentration gradient. So this is what I have mentioned here. See here, concentration, the diffusion current depends upon the concentration gradient. So the diffusion current is current density Jn proportional to dN by dx. The same thing we can write for p-type also, that is for holes. How can we write? Jp proportional to dP by dx. So dN by dx and dP by dx are the concentration gradient for electrons and holes, right? To remove this proportionality, I am going to introduce the constant, that is Jn is equal to E into capital Dn into dN by dx. Okay, so this is the constant. What is the constant? E is the charge of the particle and Dn is the diffusion constant. What is the name? Diffusion constant. Same thing I am going to write here also. So Jp is equal to minus E into dP into dN by dx. The diffusion will be in opposite direction. For example, if the electrons are moving in this direction, means the whole movement will be in opposite direction. That is the reason I mentioned the diffusion, I mentioned in negative sign, with a negative sign. So Jp is equal to minus E into dP into dP by dx, right? So combinedly I can write the diffusion current density due to electron, this is due to holes. Okay, so now where okay, dN by dx and dp by dx are the concentration gradients. What is concentration gradient? Difference. Okay, concentration gradients of electrons and holes respectively. Next, dp and dn. dn and dp are the diffusion coefficient. Coefficients of electrons and holes respectively, right? So now I have to combine both, due to electrons and holes both to be combined to get the overall diffusion current. So now the overall diffusion current density due to electrons and holes can be written as okay, so J is equal to Jn plus Jp. Okay, here Jn is nothing but E dn by dx minus E dp by dx. So here the common term is only E, I take outside. So it will be dn into dn by dx minus dp into dp by dx. Okay, so this is the overall diffusion current density. Okay, if you want to find the current density for the semiconductor, we have to combine J drift plus J diffusion. Okay, this is what the overall current density. So you have to remember this formula, right? Separately we have discussed for diffusion as well as for drift. Okay, so this is what the diffusion current. So in case of conductors only drift current is possible, but in case of semiconductor both drift and diffusion current are responsible for generating current in the semiconductor. And moreover I discussed the definition part as well as in which direction the current will be flow, and then what is the expression to represent the drift current and then diffusion current due to electrons and holes. Everything we discussed here. So you just go through it. If you have any doubt, you just ask in the comment box. Okay, thank you everyone.